So in this tutorial, we are going to cover the topic Stack's data structure, and Stack is a very important data structure, and we will see how this Stack data structure is useful in some scenarios. So first of all, let me just give you an example, a real life example of how Stack looks like. So let's suppose you have a glass tube. So let's suppose this is a glass tube which is open from one side and closed from one side. So this is an glass tube. And let's suppose there is a student and I want the student to put some balls inside this glass tube. So let's suppose there are 4 balls and I have numbered these balls from 1 to 4. So 1, 2, 3 and 4. So these are the 4 balls, and this is a glass tube which is open from the one side and closed from the another side. So I will just write this side as the top side and this side as the last side. So let's suppose I say I assigned a student to just put these balls inside this glass tube in the sequential order. So what the student will do is he will first insert the first ball inside this glass tube, then he will insert the next one, and then the third one, and at last the fourth one. So the result will be like this. Our glass tube will look like this. Number 1 ball, then number 2 ball, then number 3 ball, and then the last one, the number 4 ball. And this is our glass tube. So this glass tube can be considered as an example of a stack. And the balls that you are inserting inside this glass can be considered as the data. So now I say the student that you will have to take out the second ball. So now I have assigned the student a task to take out the ball 2. So how will the student take out the ball 2? The student will first have to take away the ball 4 and then the ball 3 out, and then only the student can just remove the second ball from the tube. So this is the basic idea behind a stack. So there are 2 operations that we perform on stack, that is the insertion and the deletion. Number 1 is insertion and number 2 is deletion. And we refer these operations as push in case of insertion and pop in the case of deletion. So let's suppose you have an array of 4 numbers or 4 integers, and now you want to add this in the stack. So the basic idea of a stack is like this. For insertion, you will have to insert the first element and then the second element goes in, then the third one, and then the last one. And in case of deletion, you will first have to delete this element, the last element, and then you will have to delete the corresponding elements, and then you will, whenever you will reach the element that you want to delete, then only you can delete it. So in the previous linked list data structure, whenever we want to insert an element, we have the flexibility to insert the element at any random position. Like if there are nodes in our linked list, you can add a node at any position. So this is null. So in a linked list, you have flexibility to add, or I should say insert, a node at any specific position. But in case of stacks, this is not true. In case of stack, we cannot insert the element at any random position. And this is the basic logical form of a stack. So this is the logical form of the stack. So the stack can be considered, there is a rule, and we are going to define a rule for insertion and deletion in the stack, and that's the reason why we are calling it as stack. So the rule says LIFO, LIFO. LIFO rule means last in, first out. So this rule says that the item that we are going to insert in the last of the stack is going to become the first element to get out of the stack. As you can see here that the last element is 4, so it is going to be the first element to get out from this stack. So last in means insertion is at last, or you can say insertion at the end, and whenever the element that is inserted at the end is going to become the first element to popped out of our stack. So this is particularly, it is different from the linked list structure in the way that the insertion and deletion, or now we're going to represent insertion and deletion as push or pop. So pushing and popping the elements in a stack is in the order of the LIFO, and that's why stack is also known as the LIFO data structure, because the last element inserted inside the stack is going to become the first element to be popped out of this stack. So this is the main point here, and this is the basic idea of how a stack look like. And let's suppose this is our stack, and the insertion, one important point is the insertion and deletion takes place at the same end. So this means that if you, or you can say the push and the pop takes place at the same end. This means that if you have inserted an element at this end, then the deletion will also take place at this end. So let's suppose you are now inserting 5 to this stack. So you are going to insert 5 at this end, and let's suppose you want to pop out the 5, then you are going to pop out 5 from this end. So the insertion and deletion takes place at the same end. So this is how our stack data structure look like, and it is basically different from the linked list data structure because it does not provide the flexibility to insert and delete the nodes or the data elements at any position. There is a rule, and the rule is the LIFO. So you are going to follow the LIFO rule to insert and delete, or to push and pop the element inside the stack. And this stacks is useful in scenarios when you want to access the least recently used. So I am going to write the application of a stack. So one major application of a stack is, let's suppose you have a problem that says that you want to access the least recently used item of particular records. So the first item that is inserted in the stack is the least recently used. So in that way you can actually access the least recently used data. Least recently used data element using stack. And this application is useful in a lot of places. So in this tutorial I've just covered the concept of stack, and we have just written this rule, this LIFO structure rule, and now we know that the insertion and how push and pop functions will take place in case of a stack. They are going to take place at the same end. So if you are going to insert an element, it is going to become the first element to come out of the loop. So in the next tutorial we will write the implementation of stack. We will implement two functions. One is the push function and another one is the pop function, and we will implement these functions in our IDE in C++, and we will implement stack data structure. And after implementing that, it will become more clearer to you. We will use this golden rule of LIFO data structure to implement these functions push and pop. So remember that insertion and deletion, or the push or pop function, has this rule LIFO. So the last element inserted inside the stack is going to become the first element to get popped out of the stack. So thanks for watching.